In this project, I'm going to use infrastructure as code concept to create an application infrastructure on Azure from scratch. We will support multiple environments and we will use ARM templates and PowerShell to create this infrastructure. As you can see here on the right, I will create a Cosmos DB account, and then we will create a database and then a collection in this database. We will also create an app service plan and then an application within this app service plan to host our microservice. I will also create a small blogs microservice, so we will build a RESTful API as the backend for a small blogs microservice. I will use Nodejs, TypeScript, and MongoDB, and we will deploy to Azure and connect to Cosmos DB and see it running in production. There are some prerequisites to be able to follow along with this project. First, you will need to have an Azure account. Now, you can easily create a free Azure account. I will leave the link in the description, and you can also search online how to create an Azure subscription. And also, you will need to know a little bit about Azure. You don't need to be an expert, but at least know some concepts. Then I'm going to use Node.js, so you will need also some familiarity with Node.js in order to follow along. I'm also going to use TypeScript. If you have not used TypeScript, it's okay, you can still follow along. Now I'm going to use VS Code. You can of course use any IDE, but if you are using VS Code, then you can use the same extensions that I am using in this project. So before start creating the templates for our resources, we will need to have the following extensions installed. First is the Azure Resource Manager tools. This will help us create and validate the Azure templates themselves, and it will provide some snippets and code completion. The second one is the Azure Resource Groups. I will use it just to view and verify the resources that the template will create. And then the Azure Databases, this one will help us browse and query the Azure databases. So I will use it to query the MongoDB that we will create. And then the Azure App Service, I'm going to use this one to quickly deploy the node application that we will create. Okay, so I created this folder for this project, and within it I'm going to put all the infrastructure code. Now, usually I will put the infrastructure code in its own repository, and then it will have its own build and release pipelines. But in this case, and to keep things easy, I'm going to keep the infrastructure code and the web application itself in the same repository. So I created a file called resources.json where I'm going to define all the resources for the project. Now there are various ways you can start writing the ARM templates. You do not necessarily need to start from scratch. You can go to the documentation, for example, the ARM templates documentation, and here you can search for the resource you are looking to create and read a little bit and see the examples provided, and then you can copy, paste, and start from there. Another option is to go to the GitHub repo for Azure Quick Start templates, and then you can also copy some template for the resource you are creating and modify that one. Now here, because I want to use specific API versions, then I have already some template that I'm gonna copy paste one piece at a time. So I'll start with an empty template. Okay, so the first resource we will need to create is the Cosmos database account, and we can create it using the snippets. As you can see here, if we use the snippets, then we can just fill in the missing pieces and then we will be ready to go. Now for me, I'm not going to use the snippets because I want to use an API version that is newer than this one. And so I'm just going to copy paste the description for the resource. Okay, so I added this one, and as you can see, it looks similar to the one generated by the snippets. It just uses a newer API version. And also, as you can see, there are some parameters and variables, and they are still missing from the template, so we will need to add them. Now for the Cosmos account name, we will need to define a variable here. Now usually you will have a naming convention for all of your resources so that you can easily distinguish between resources belonging to different environments and different projects and so on. Here I'm going to follow a simple naming convention just to distinguish between the environment, and also I'm going to add the project name. So I've added a parameter called environment name, and in this project I'm only going to have two environments, development and production, and the project name. And as you can see, the project name has a default value of Omniverse, while for this one we will need to specify it using the parameter files. Now we can define the variables. So I usually create some resource name prefix for all my resources. In this case I will create it as a concatenation between the environment name and the project name, and then all the resources will have consistent namings. Okay, now that we have the database account, we can add the database. Okay, so this will create a MongoDB inside the Cosmos DB account we've just created earlier. And you can see here that we are missing the database name as parameter and also the throughput. Okay, next I'm going to create the collection. And now we can create the resources for the web application. So in order to create a web application, we will need to have an app service plan. And so to do this, we create a resource of type server farms. As you can see here, it's just a very typical. I will have it as a Linux machine, and I will also specify the SKU. Usually you will vary this SKU between the development and other environments, so you will probably increase it in production. And also I will give it an app service name following the same naming conventions. Okay, so the last resource we need is a web app to run the Node application. All right, so this web app will run on the app service plan that we've created earlier, and also we will put a name following the same naming conventions. And as you can see, the app settings, I have specified all the connection details to the MongoDB as part of the app settings. And this means that when we deploy the Node application, it can access these app settings using environment variables. So this is a very convenient way to give the web application access to the connection details without shipping them with the application itself. So there are many ways to deploy the Azure Resource Manager templates. You can do that using the Azure portal. You can do that using the Azure CLI. You can do that using Azure PowerShell. You can also do that using a REST API, and of course we will usually do that as part of the CI/CD system. So if we are using Azure DevOps, then we will create build and release pipelines for this. For now, I'm going to deploy this from my local machine, and I'm going to use Azure PowerShell for this. So I'm going to create a PowerShell script that will create the resource group and then apply the template file. Okay, so this one will create a new resource group, and then within it, it will apply the template that we supply as parameter. And now I need to mention that you need to have PowerShell installed on your machine. And so if you are using Mac, then you would need to install that. Okay, as you can see, I already have it. If you do not, then it will install it. Now, one more thing, in order to be able to run the Azure PowerShell commands, we will need to make sure that the Azure PowerShell module is installed. So I'm gonna add a check to make sure that it is installed. Otherwise, it will install it in the run file, and then I'm gonna call the deploy method with the parameters for the development environment. Okay, so this snippet here, it will install the Azure PowerShell modules if they are not installed, and this snippet here will deploy the resources to the development environment. So I've called my resource group for development dev-omniverse-rg01, and then I chose the location as North Europe, and then I supplied it the resources file and also the parameters of the development environment. So the subscription I'm going to use is this Visual Studio Enterprise subscription, and as you can see, it's completely empty. And now once we run the script, we can come here and verify that all the resources that we wanted to create are actually created. So before running the deploy script, you will need to log into your Azure account. All right, now I'm logged in, so I'm going to run this script. Okay, as you can see now, it succeeded creating all the resources, and also previously it complained about the resource group.location. So apparently here in the parameters file, it does not evaluate the expressions, and that's why I removed the location parameter from the parameters file and just used the default value in the resources file. But after that one, I ran the script again, and then it says that the resource group is already existed because it created the resource group, and then you can update it. And then this one succeeded, and then all the other resources also succeeded. Okay, so here in the portal I can see that the dev-omniverse-rg01 has been created, and then inside it 3 more resources: the app service plan, and then the app service, and then the Cosmos DB account. Okay, so the database has been created, and also the collection blocks has been created. As you can see, also the connection details to MongoDB have been added as application settings to our app service, to the blogs app service, which means that now we can use them as environment variables inside the app. Okay, I'm going to create the web app as the backend for a blogs microservice. So we will have a single endpoint called blogs that will support CRUD operations over the blog resource. To create this, I'm going to use Nodejs, and particularly I'm going to use a framework called Nestjs. So Nestjs, as you can see here, it's a progressive Node.js framework for building efficient, reliable, and scalable server-side applications. I think this framework is nice because it helps you structure your code in a way that supports solid principles. So Nest comes in 2 flavors. You can use vanilla JavaScript, or you can use TypeScript. I'm going to use the TypeScript. Okay, so in the documentation of the Nest.js, we can read about how to spin up a new project. I'm going to spin up a new project using the Nest CLI. So this created a new Nest project for us, and you can see here that I started a project and then I verified that it is working correctly. So I'm just going to clean up some files here that I know I'm not going to use for now. Alright, so in the documentation about Node.js, you can read more about the design philosophy and also the building blocks and the main concepts of the framework. But essentially, it revolves around the concept of modules. So everything is a module. And then when you want to create some new functionality, you will create that as a module. And then you have the app module, which will combine all the child modules. So to start with, I'm going to create a module for the configurations. So everything in the app that is configuration, I'm going to group it in a module for configurations. And then I'm going to create another module for the database so that it will encapsulate our connection to the database. And then I will start creating modules for different features in the application. We will need 2 files, one that represent the configuration service and another one that represent the configuration module, which will expose this service to the rest of the application. Okay, so following the 12-factor app methodology, it suggests to store the configuration in the environment. And so I'm going to store all the configurations for this application into the environment variables. And so I'm going to use a package called .env, and this will help us load environment variables from a .env file. And now we can start developing our configuration service. All right, so the configuration that I need for this application are essentially the connection details to the MongoDB. Okay, now I'm going to create another module for the database. And so this will encapsulate the connection to the database. And so other modules in the application can just import this module when they need a connection to the database. Now for the database module, we will need to connect to the database. And since we are using MongoDB, I'm going to use a package called Mongoose for connecting to the MongoDB from Node.js. So I'm going to install this package first. We'll also need to install the TypeScript types for this package. And we need to do the same for the .env package. Alright, so now to create a connection to MongoDB using Mongo, I'm going to follow the recipe in the Nestjs documentation. And so I'm going to create a database provider that will provide the database connection to other modules in the application. Alright, so in the source folder, I'm going to create a subfolder called database. I'm going to set up the database provider there. All right, so I've created a provider, and now this provider is going to be injected using a property and not constructor. And essentially, just any module that will ask for this token, it will get this provider injected. And then I created a factory for this one, and then the factory uses another function here that will try to create the connection to the database. And if it fails, then it will keep trying for 20 times. All right, now we need to make this a module. So I'm just going to remove this magic string to a file called constants. So in the configuration module, I created another file called constants where I will group all the constants for the application. And then in the database provider, I'm going to replace this one with the token coming from the constants file. All right, so now that we have the common modules ready for our application, we can start creating the resources modules. And the only resource we have in this application is the blog resource. And so I'm going to create a blog module to encapsulate all the blog functionality. So in the source, I'm going to create a folder called resources, and within it, I'm going to create another folder called blog. So to create the schema for the blog entity in MongoDB, we will need to use the schema object from Mongoose. I'm going to create a very basic entity that will only have a blog ID, title, and text. And also I'm going to add timestamps to it. Now in Mongoose, to be able to interact with the database using the newly created schema, we will need a model. And so I'm going to create this model in the provider file. Okay, so this will create another Node.js provider that will provide the model for the blog entity. Now I'm gonna create a repository to encapsulate all the interactions with the database. So this model here will be of type document, and to define proper types for TypeScript, I'm going to create an interface called blog that will extend the document object from Mongoose so that we will have a strongly typed model for the blog here in the repository. Okay, so now we can use this object to do all of the interactions with the blog collection. Okay, so the first method I'm going to create is one to create a blog. It will take title and text, and then it will return a blog entity. I'm going to create two more functions to get all the blogs, and then another one to get a blog by ID. Two more functions, one to delete and another one to update. Okay, so now we can move to the service layer. Inside the blog, I'm going to create a file for the blog service. Okay, so the blog service will use the blog repository for all the database interactions, and that's why we need to inject it in the constructor. Another thing I'm going to create is a blog model so that we isolate the models that the service uses from the models that the repository uses. Okay, so here I'm just going to basically repeat the 5 methods we had in the repository. Okay, so all of these service methods here are almost a copy of the repository ones because we do not have any business logic. But in most applications, you will have some business logic and you will have some information that is incoming, maybe not from the database. And so you will need to combine all of this logic here in the service layer. And now finally, we can start creating the controller. Okay, so the first method I'm gonna create is one to handle a post request and so to create a new blog. So in this function, we would need to call the service method to create a new blog. But first, we would need to get the blog details from the request body. And for this request, I'm going to create a separate model so that we prevent overposting. Okay, next I'm going to create two functions for the HTTP method get, one that will get all the blocks and another one that will get a single block. Next, I'm going to create another function for the HTTP method delete that will delete a blog. It will also receive a route parameter just like this one for the ID of the blog to be deleted. So the last function we need is the one that responds to the HTTP method put. And for this one, we will need a route parameter, which is the ID of the blog. And we will also need to receive request body. So for the request body, I'm going to create a separate model and I'm going to call it update blog DTO. Okay, so now we have the block controller ready, and now we need to make this a module. Okay, so this defines the block module. It states that it imports the database module because it depends on it. And then it has one controller, the blocks controller, and then it provides all of these submodules, but it does not export any of them. We can delete the app service file. We don't need this one. And now we can fix our app module file. Okay, so our application module will only have the config module and the blog module. Okay, so the last thing I'm going to do for this app is to generate the Swagger page. Alright, so now we can fire up the app and test the API. So as you can see here, I've started the application and then we can see the Swagger documentation. One thing I corrected is that back when I created the resources, I specified a shard key for the collection. So in the schema, I've added a tenant ID, and also in the interface, I've added a tenant ID. And in the repository, when creating a new blog, then I'm just going to specify the tenant ID to tenant1. This is not a multi-tenant application, and so it might make sense to specify the sharding key as something else. Alright, so now let's try to test the API. Alright, so I'm going to test the API with the MongoDB in Azure directly. So I have specified the environment variables here to point to the development database on Azure, just to make things easier and more fun. So in Postman, I'm going to specify our endpoint, the local one, because we haven't deployed the application yet. And then I'm going to try and create this. So this creates a new block with a new block ID. And now if we check in Azure, we find that a new entity has been created. Now let's try to create another block. All right, also the second block got created. Now let's try to get all the blocks. And we can see we have two blocks here. Let's try to get one block by ID. And we also have our block. Let's try to delete the first block we created. We find that the first block got deleted, and then let's try to update the second block. Alright, so our API seems to be working and now we can deploy it. Alright, so now we are ready to deploy our application to Azure and the development environment that we created in the first part. Before that, I just need to mention 3 changes I made to the code. First, in the main.ts, I am now listening to the port taken from the environment variable. This is important in order for this app to run on the web app in Azure. The second one is that I changed the Node version of our web app, so I am now using 12 long-term support. And the third change is related to the way that we are going to deploy this application. And so what we need to do in the package.json file, I've changed this one from start colon prod to start without prod. And then I called this one start colon nest. This is very important because the automated deployment I'm going to use, it's going to run npm start to start our application. All right, so with these changes done, now we are ready to deploy the app. Now I'm going to deploy this app using the VS Code extension that I have installed earlier, which is the app service extension. And so if you click here, this will deploy the application to the web app. Before that, of course, you will need to connect to your account and your subscription. I need to mention that this is not the recommended way to deploy your application. So the recommended way, of course, is to use a continuous integration, continuous deployment system like Azure DevOps, for example, or GitHub Actions. For now, I'm just going to make it easy and deploy it from this extension here. Okay, so to deploy using this extension, I've already logged into my Azure account, and also I have chosen the subscription, and then I could see the web app. And then if I click here and then choose the API application, this will kick off the deployment. Okay, once the deployment is completed, you can see deployment successful, and then you can also browse the website or start streaming the logs. Now, if I navigate to the website, then we can see our Swagger documentation, which means that the API is up and running on our development web app in Azure. And now I'm going to use Postman again to test the application on Azure. So I have changed the URL here to point to the development environment on Azure, and then I'm going to try to create a new blog. Alright, so we can see that the blog got created. Let's check in the database. I'm going to use the VS Code Azure Databases extension that we have installed earlier to view the newly created blog. As you can see here, we have 2 blogs, one an earlier blog, which is the one that I created when I was running the API locally, and then the second one, which is the one that I created as the API now is running on Azure. So let's try to get all the blogs. Great, and we can see that we got both blogs. Let's get the new one. Okay, so we can get single blog and also all the blogs. Let's try to delete this blog. So the document got deleted. Let's try to update this one. Great, seems to be updated. Let's check the database. All right, so as you can see, our API is up and running on Azure on the infrastructure that we created using infrastructure as code. And now it's super easy to replicate the app and also the infrastructure by running this script for another environment.